So what I'm talking about today is the follow-on from the talk I gave last week. So last week, for anyone who wasn't here, I talked about the FHIR terminology services resources. So that's the value set resource, the code system resource, and the concept map resource, and a little bit about what the fields are on those resources, what they're used for, and how you build up some of those resources, particularly value set, which is a little bit complicated to use. You need to combine include statements and exclude statements to get the list of codes that you want. What I'm going to talk about today is the operations of that FHIR Terminology Services API, which moves a little bit away from authoring terminology content, so creating code systems or value sets or maps, and a little bit more into using terminology content, whether that's runtime use, for searching for codes directly from a clinical data entry scenario, or maybe just build time use if you just need to extract a set of codes in order to populate a table that you're going to use in your system. So these are the operations that you use once you've got the terminology in your system, and you need to be able to either populate an external tool or drive functionality at runtime. So I will give a little recap for some of the motivation that I gave last week. So as we heard last week, terminology is the basis of shared meaning between different systems when we're using health data. Structure definitions or the information model that we're using might be the skeleton of the data that we're sending around, but terminology really is the muscles. It's where the meaning lives. It's where we differentiate diabetes from cardiomyopathy or other conditions. It's where we differentiate paracetamol from codeine in a medication resource. It's where we differentiate a regular consultation from a heart bypass in a procedure. In a large integrated system, it's very useful to have a single reference for terminology, so that there's one place that you can go when you want to work out the latest set of codes that you're dealing with. And externalized terminology can be really valuable as well, because it means that there's a single place you can go to update to a new version of terminology, or to a new terminology if you need to do that. And then all the systems that need to use terminology could automatically be updated by that. But those things are not the only way of doing it, and the API can be used either for an external service or a centralized service, or for individual services. So when we're using FHIR, or when we're not using FHIR, because the FHIR Terminology Services API is very useful, even if we're not using FHIR as our information model, there's a range of use cases where the terminology services operations can help us. So if we're doing data entry, whether that's clinical data entry or patient-reported measures, or perhaps some sort of operational data being entered by an administrator, the terminology services operations help us to quickly find the right code to record in a specific context. In a validation scenario, so where we've received some data or we've encountered some data, we want to check whether the codes in that data are appropriate for the context in which they've been provided. For display and understanding, if we are looking at a number of codes, perhaps we're assessing candidate codes for inclusion into our system for the next time we update. We want to be able to see how those codes relate to other codes in the code system, and perhaps how they relate to other codes in other code systems. If we're building maps or we're using maps, tonight will be more about using maps. We often want to find a code in a code set that's related to the code I have from this set. So being able to take a map and actually apply it to a source code to obtain a target code or more target codes. If we're doing analytics, we want to be able to arrange our coded data, so perhaps group codes into a set or map them up to a category, or sort of otherwise arrange them so we can start getting insight into the coded data. And then from an authoring point of view, we need terminology as well, but most of that we covered last week in last week's presentation. Finally, if we do have a FHIR service, such as a happy server that stores clinical data, we often want to connect it up to our terminology server so the clinical data repository can be smart about terminology. So we can ask it questions such as, give me all the condition resources that have a code that's in my specially curated chronic diseases list, or show me all of the conditions that are diabetes or one of its descendants in the hierarchy. And the terminology server can help with that kind of functionality. So I won't spend long on this week. There are 3 data types that the FHIR specification uses for terminology. There's the code, which is just a code. There's a coding, which is a system and a code. And there's some other optional attributes as well, including the display text. And there's a codable concept, which is a number of codings, 0 or more codings, as well as a textual representation of the concept as well. And then there's some syntax for supporting search of coded data as well, using the token data type. And if you're interested in that, please do have a look at last week's presentation, or consult the FHIR search page, which goes into the token data type and how to use it with terminology, with coded fields. Just as a quick example of these 3 data types. So in this example that we're looking at here, this is an encounter resource encoded in FHIR. If you don't understand JSON, if you're more from a clinical or business perspective, I am going to show a fair bit of JSON in this presentation, but if you don't understand it, it doesn't really matter. The purpose of the operations I'm describing is still useful, even if you don't understand the nitty-gritty detail of the data formats that for the input and output parameters. The valuable thing, if you're coming from a more clinical or business perspective, is to know that what operations are used for what purpose, and I will cover that. But just as an example, here in this JSON, the status field is a code typed field, so it just has a code. The class element in this field is a coding typed field, so it has a system as well as a code. In this case, the system is the URL for the v3 act code system. And then the reason code element in this example is a codable concept typed field. And in fact, it's a multi-valued codable concept type field. So in this case, we have one codable concept which contains 2 codings. One is a SNOMED coding and one is an ICD-10 coding. And there's a textual representation of the concept as well. So just as a quick recap of last week, the 3 resources that are really interesting in the terminology part of the FHIR specification are code system, value set, and concept map. There is a 4th that came up in questions last week, the naming system. Naming system allows you to specify the URL or the OID or some other identifier for coded values, but it doesn't actually allow you to describe the content or a lot of the other metadata for those coding systems. So it's not something that you would use if you're able to represent all of the codes. But if you've got something like perhaps a clinician identifier or a patient identifier system where you don't know all of the codes and it's not useful to express all of the codes, but you do want to say that this is an identifier system, then naming system is a resource that you can use for that. Naming system is not a normative resource. By contrast, code system and value set, which we see on this diagram have an N on them, those are normative resources in the R4 version of FHIR, so they're very unlikely to change as the FHIR spec continues to evolve. So a code system resource is a set of concepts with a coherent meaning. It has a range of metadata. Most importantly for tonight, it has a URL and a version, and these are the fields that we use to identify the code system, for example, when we're referring to that code system from a value set. It can define properties on the code system, and then it can populate those properties for each concept that is defined in the code system. So each of those concepts can have a code, or will have a code, can have a display text, can have a definition, which is a longer sort of description of what the concept represents. And then it can have a range of property values. It can also have designations. So designations are used either to describe synonyms of the concept or to define translations of the display text of the concept. When we want to use code systems, we usually do so by creating a value set. So a value set is some selection of codes which has been assembled for use in a particular context. So those codes might come from a single code system, or they might come from multiple code systems. And then the value set consists of a bunch of rules. Some rules might be as simple as code A, code B, code C, but others might be more complex based on the properties of the codes or the or whether they belong to a certain other value set. So the value set will build up these rules to define which codes are or aren't members of that value set. And we'll see how to interpret those rules in a moment. The third resource is the concept map resource. So a concept map resource is a set of mappings between concepts in one value set and concepts in another value set, as well as an equivalence relationship. So this is whether the codes are determined to be equivalent according to the concept map, or whether the target code is broader than the source code or narrower than the source code, or whether it's just a general relationship that doesn't go into broader or narrow or equivalent. So concept map, unlike code system and value set, is not normative. It's at about maturity level 3. There are some changes still happening to concept map, but it has been in use for a while. So it's not a resource that's going to go away completely, but some of the details about it might change before it becomes normative. So we can interact with these resources using the standard FHIR SCRUD operations, so search, create, read, update, and delete. And we do that using the HTTP verbs, the gets and posts with the URLs that are listed here. When we're using operations, we also use HTTP interactions. So depending on the operation itself, it can either be defined at the root level of the FHIR server. There's only one that I'll describe. I think I described that one tonight. Or it could be defined at the resource level. So the name of the resource / operation, such as value set / $operation. Or it can be defined at the resource instance level. So where you actually provide the ID of the specific resource that you're interested in. And it depends on the operation itself as to which of those three paths on the FHIR server will work for that operation. We can either invoke the operation by using a GET request if it's what's called an idempotent operation. So idempotent means that when you call the operation multiple times, you will always get the same response. If there are operations that are not idempotent, then you must use the post form of the operation. And you do that by passing in a parameters resource as the body of that post request to pass in parameters. Whereas if you're using a GET request, you can usually just pass in the parameters in the URL of the request. So the first use case we're going to look at is data entry. So if you're designing interfaces for data entry, whether that's data entry by a clinician or data entry by an administrator or data entry by a patient, the first thing you usually want to do is you choose the code system from which the codes that you're expecting to receive will come. Now, hopefully you're able to choose a standard code system. Maybe it's ICD-10, maybe it's LOINC for pathology data, maybe it's SNOMED CT, or some other standard code system. Maybe it's TMT for the Thai medicines terminology. Or possibly you need to define your own code system. So if it's proprietary codes that you're expecting, then you may need to define your own code system resource and add that to the server. Once you've done that, you either choose or define your value sets. So maybe you're able to use a value set that already exists on the server, or maybe you need to define a new one and add it to the server. Then once you've done that, if your value set is small, you might be able to use a pick list user interface element. So a drop-down menu, for example. And then you can retrieve the members of that value set that you need to put in the drop-down using the $expand operation. More commonly, the value set that you need to search is going to be large. And I would say this is anything beyond sort of maybe 10 or a dozen codes. You really want to be supporting type ahead. Certainly, but once you get above 50 codes, you definitely shouldn't be using a drop-down menu. You want to be allowing the user to use type ahead search. And you can do that by using the expand operation with a filter parameter where the value of that filter parameter is the text that the user starts typing. So as they type, the set of matching codes will shrink until they find the code that they want. So I'm just going to give a quick demo. I'll just have to fix my sharing here. How do I do this? I'm just going to share my web browser. If I can find it. Okay, so this is just a quick example of a user interface that has been built to demonstrate the use of the FHIR terminology services operations, in this case with SNOMED CT, but the expand operation works equally well with any terminology that exists in your FHIR terminology server. So as I said, for really simple interactions, we might use a drop-down, but for larger value sets, such as a reason for an encounter, which could be as many as hundreds of thousands of codes, then you're going to want to use type ahead. So we can just say that there's a foot joint pain. It's the concept that we're looking for, and there we've selected the concept. And if we, I think if we hover that text. Behind the scenes, it's using SNOMED CT code. And the fact that we can't see what that code is actually an example of good user interface design, because most of the time, neither a clinician nor a patient, for example, nor an administrator really cares what the code is. What they care is what the concept is. So it does make sense for us to not show that code in the user interface, because it's not what's important to the user. What's important to the user is in this case, the preferred term of that concept. As I said, if we have large fields, we're going to want a type ahead. If we've got a smaller field, so for example, here we've got a laterality. So I've selected that the procedure is an excision of the lung. We're going to take out the patient's lung, and we want to select the laterality. And because this is a very small value set, we can just use a drop-down menu because there are only 4 possible values here, including undefined. So we're going to take out their right lung. So that's an example of using the expand operation to populate that. And we can see other examples on these other screens. So sex here, we've got a drop-down menu because it's a small value set. We can also have just checkboxes here if we've got a small value set as well. So we can say former smoker, and we can say that they were a cigar smoker. So all of these are possible user interfaces, and all of these are using the expand operation. The type aheads using the filter parameter, and the others just using the expand operation without any filter parameter. So if I go back to my presentation, we can have a look in a little bit more detail at this expand operation. So the expand operation allows us to retrieve the expansion of the value set subject to a number of parameters. So what this means is that the value set is defined as a set of rules that dictate which codes are members or aren't members of the value set. And what we need to do when we're searching for codes in a value set or listing the codes in a value set is we need to evaluate those rules and find the list of codes that actually satisfy our search. So that's what the expand operation does. The result of that expand operation is another value set, and it's another value set with the expansion element of that value set populated. So when the value set comes back, and we'll see an example of this in a moment, that expansion element will be populated by all the codes that match the request. So if the request had a filter on it, it'll be codes that match the filter. And then there's some other parameters we can pass through as well. So the most important of those are to say which value set we're interested in. And we can do that using either the URL parameter to specify the URL of the value set that we're interested in, or we can use a context. So if we don't know the URL of the value set, but we do know which FHIR element we're interested in, so for example, maybe it's patient.gender, then we can pass in a context parameter, or we can actually just pass in the value set definition itself. So if we're making an HTTP post request to the server, we can just pass in the definition of the value set with the expand request, and then the server can just do it on the fly. As I've said, the filter parameter allows us to provide a text filter that narrows down the set of concepts that come back according to some text filter, which is really useful for type ahead user interfaces. Often the expansion value sets that we get back will be very, very big and bigger than we want. So we can use the count and offset parameters to page through those results. So the count will limit the number of concepts that come back in a value set expansion. And if we want, for example, we've already looked at the first 10 results and we want to look at the second 10 results, then we can use offset to say we want that second page of concepts. Then there are a few parameters that we can pass in that change the level of detail that we get back about the concepts. So the include designations means that all of the synonyms or translations for the matching concepts will also come back in the expansion. Include definition means that those rules that were originally there to define the value set, as well as the metadata for the value set, those will come back too. Active only allows us to limit the result to only active codes. And then we can use display language to say, for example, that we want the display text of the concepts that come back to be in Thai or English or French or whatever language. So this is the main operation that we use to search for code. And I'll show a few examples here. So this first example is an expand request of the administrative gender value set. So I'm specifying that by passing in the URL of that administrative gender value set in the HTTP GET request. And when I do that, the server comes back with a value set. As I said, it's got that expansion element populated. And that expansion element has a contains element, which then has all of the concepts that are in that value set. Now, I didn't filter for this expand request, so it's just going to be all concepts. And because value sets can include codes that come from different code systems, each concept in the expansion will have not only a code and a display text, but it will also have the code system URL of that code as well. So in this case, all 4 codes come from the administrative gender code system. And then I can see that the male, female, other, and unknown codes have come back. This second example is an example that uses a filter. So in this case, the value set that I'm expanding, the URLs there is http loink.org/vs. So that's the set of all codes in the Loink code system. And then I'm passing in, and that's an awful lot of code. So I'm going to narrow it down using a filter. So I'm filtering for urinalysis. So any code that matches urinalysis. And now hopefully our server is going to be smart enough that will search not only the display text of all of the codes, but also its synonyms. So that if there's maybe the main term of the code doesn't include text urinalysis, but some of the synonyms do, then hopefully the terminology server will be smart enough to find those as well. And I'm also going to limit the results to say that I only want the first 3 codes to come back. So I'm going to pass in that count parameter equals 3. And when we do that, the server again comes back with a value set. It has an expansion. And the expansion does tell us in that total element that there were 52 codes that did match the filter that we passed in, but we did pass in the count parameter as well. So because of that, it's only returned the top 3 codes that match that filter. So in this case, the 3 codes are down the bottom there. And once again, it has the code in the display as well as the system, the code system URL for each concept. This next example uses the context parameter. Instead of passing in a URL for the value set that we want to expand, we're just going to say we want to expand whatever value set is bound to the medication.status field. So this relies on the terminology server being aware of the terminology bindings for all of these structure definitions. And in this case, it is. So the terminology server comes back and says, yes, there are 3 codes and they are entered in error, active and inactive. And we can see it's actually told us the value set that it expanded as well, just in that expansion parameter field. So those are some examples of the expand operation. The next scenario we're going to look at is the data validation scenario. So this is where we've received some coded data. Maybe it's come from another hospital. Maybe we're gathering data for research purposes or something like that. And the first thing we want to do is we want to check whether the coded data in that, the coded values in that data are legitimate codes for the fields that they've been provided in. So when we're doing that, the first thing we need to do is to work out what we consider to be legitimate data. So we need to choose the code systems that we're going to accept and define value sets over those code systems that capture all of the codes that we think are permissible for these fields. Once we've done that, we can use the validate code operation, which we're going to look at, to check whether the codes that we've received are valid members of those value sets that we're interested in. And we can also use the validate code operation to check whether the display text for those codes is acceptable as well. So we want to avoid that scenario where someone has selected cancer as a concept in their data entry field and then changed the display text to say probably not cancer or something like that, which is very, very unsafe from a clinical point of view, but does happen, unfortunately. We might also want to do some other things as part of our analysis. We might want to use Translate to map some of the codes that come from other code systems across to a standard system before we do analysis. And then we might want to do some queries of the hierarchy of the code system to either map the codes up to categories or things like that. But first, we're going to look at this validate code operation. So this is an operation that we can use against a value set to check whether code is a member of that value set. And optionally, we can also check whether the display text is valid with respect to that value set as well. So we can either use an existing value set that exists on the terminology server, and we can do that in the same way as we did for expand. We can pass in a URI for the value set, or we can use the context parameter, or we can, and that includes using implicit value sets. So I think people who were in my talk last week will remember I talked about implicit value sets that exist on the server without you having to create them. And then another option is to actually post the value set across to the server as alongside the validate code request. So you just make up a value set on the spot. We pass through the code either as a code and a system. We can optionally provide a version as well, or we can pass through a coding or a codable concept. For those last two, we will have to use an HTTP post request. You can't express those in a HTTP GET request. And then the operation will determine whether the code is included in the value set, and we'll see how that comes back in a moment. If you pass in display text along with the request, then the server will also check whether that display text is acceptable for the code. And this is the main method that we're going to use for validating coded data. The validate code operation I've been describing is defined on value set. There is also a validate code operation on code system. When you use it on a code system, you're just checking whether that code is a member of that code system. So you don't have to have a value set that narrows down that set of codes. So here's a simple example. In this case, the URL of the value set that I'm providing is the set of all concepts in SNOMED CT. So that's an awful lot of codes. And we're going to pass through the code in the form of a system to say it's a SNOMED CT code, and it's the code is this 383620002 code. And the reason we have to provide the system is because that it's possible that that value set would include codes from multiple different code systems. So we would need to know whether the code we're passing in is from code A or code B. So we always have to provide that system parameter. And in this case, the server comes back with the results. Usually the validate code operation is very fast. And it's said that the result of the validate code is true. So that code is a member of the value set. And just for convenience, it's also provided us with the display text of that code. So the display text in this case is dengue fever. We can also pass in display text along with that validate code request. So in this example, we're once again using the value set of all codes in SNOMED. And we pass in a SNOMED code, and we pass in a display text that perhaps our user has selected or typed in, hopefully not typed in, but it can happen when they've entered their data. And this time the server comes back and says false. And in the message, it explains that the code is in the value set, but the display text that you've provided, hypercholesterolemia, is incorrect. And in the result, it's also provided the correct display text, which is hypercholesterolemia. And in this case, it's just a spelling error. So you'll see near the end of the word, the correct text has AE, and the text that we provided had just E. So the server has picked that up. The next scenario that I'm going to present is when you're just exploring for the relationship between codes and for information about codes. So when we do this, we're going to use mostly the lookup operation. So the lookup operation allows us to retrieve all of the details about a code that exists on the terminology server. So this includes all of their properties, its display text, and so on. If we are exploring these for information about these codes, the other thing we might want to do is use the child and parent properties, or perhaps use the subsumes operation or the closure operation to explore the hierarchy that exists between those concepts. So we'll see an example of that as well. So just before I illustrate this, I'm going to switch across again to a quick demo. In this case, it's of our Shrimp browser, which is a free code system browser that's available online. And the URL for that will be in the slides. And the Shrimp browser makes very extensive use of this lookup operation that we're about to learn about. So if we're interested in cancer codes in malignant neoplasms is the correct term in ICD-10, then we can search for that. That's using an expand operation, but when we click on one of those codes, it's doing a lookup, and we can see the results of that lookup, that all of these properties come back. So we can see that in this case, there's a coding hint and a kind. And if we were to switch across to another code system, so let's say we switch across to LOINC, and we search for malignant here, then we can see different properties on the LOINC code system. So the server is sending through one of these lookup requests. It's asking for all of the properties that the server knows about, and the server is coming back with all of these properties, as well as the display text that we can see over here, and any synonyms that exist. So in this case, there is one synonym for this LOINC code. And Shrimp is, again, free to use if you want to browse code systems. Most of what it's doing when we click on one of these concepts here is it's doing a lookup operation, and it's using that to describe all of these properties. It's also using it to populate this hierarchy as well, because some of the properties that come back in a lookup operation are the parent and child properties, which tell you the hierarchy that exists between codes as well. So if we just switch back to my slides, let's have a look at how this lookup operation works. So again, lookup is how we retrieve details about a code. We do that by providing a code in a system, or a coding if we want to use a request. And then the server will return all of the details that it knows about that code, such as its properties, its designations, its display text, and so on. We can also, in fact, what the server will do with properties is that the server will decide which properties it thinks are interesting, unless we want to tell it specifically which properties we would like. So if you send through a lookup request with just the code, the server will decide that the display text is interesting and the parent-child properties are interesting, perhaps, and maybe the active property is interesting, but some of the other properties aren't that important, so I won't return them. If we want to see specific properties, we can use a parameter to the lookup request to say which properties we want, and some of them support a property equals star, which says give me absolutely all of the properties that you know about. So in this first example, it's using a sample code system that I created for Australian jurisdictions. So this is an example of a proprietary code system. And we sent through the lookup request saying that we're interested in information about the WA code from this Australian jurisdiction code system. And the server comes back. It gives us the name of the code system and the version. It gives us the display text of the code we passed in. And it's telling us there's a synonym, a designation in this case, West Australia. And then it tells us the parent property that this is a child of AU state, this WA concept. So that's a quick example of the lookup operation. Another operation that we can use to query for information about a code is the subsumes operation. And this is an operation that lets us pass in two codes, and the server will tell us if there's a hierarchy relationship between these codes. So the server, we pass in those codes again as a code and system pair, and the server will come back with one of four results. It will either say those two codes are equivalent, code A subsumes code B, code A is subsumed by code B, or there's no subsumption relationship between these two codes. And this allows us to work out the hierarchy of the codes that we're seeing in the data that we receive. We can also use the closure operation for this, and I think I have some examples, if I have time, of the closure operation as well. So here's a quick example of the subsumes operation. So in this case, we pass in the code system. The subsumes operation always works on codes from the same code system, so we don't have to pass in system A and system B. There will never be a subsumption relationship between codes in two different code systems with the way FHIR deals with code systems. So we just pass in the one code system URL and the two codes. And in this case, the server comes back. I think one of these is the hand body structure and the other one is the finger body structure, or is a concept. So in this case, it comes back and it says, yes, the hand body part subsumes the finger body part. I did cover this last week, but I'll reiterate it again this week. There are some well-known terminologies in the FHIR specification. Some of the significant ones of these are SNOMED CT, LOIC, ICD-10. There are others. These have a fixed representation in FHIR, have metadata, in particular a standard URL that you will always use when you're using those code systems. They have standard filters and properties that should be available for those code systems, and they can come with implicit value sets and concept maps. So these are value sets and concepts that exist automatically when that code system is in the terminology server. You don't have to create them on the server each time. So in SNOMED, you have implicit value sets for all codes. You have implicit value sets for all descendants of a given code. You have all of the ref sets, all of the members of each ref set is an implicit value set. And then there's all the ECL expression constraint language. And that will be covered in a later talk, I think in maybe the next week or the week after. I think we're covering SNOMED CT. LOIC also has these. So there's an implicit value set for all of the codes in LOIC, and then for the hierarchy according to LOIC's multi-actual hierarchy as well. So the next scenario I'm going to look at is if you're mapping between codes in one value set and codes in another. So in this case, you've created a map. You've worked out all the mappings that exist between these codes, and then you want to query it. So you've received, perhaps you've received a SNOMED code and you want to map it through to a billing code for a procedure or a condition. And the way you can do that is using the translate operation. So the translate operation essentially looks up the table of mappings that exists in the concept map resource, and it returns all of the maps for the source code that you provide. It's not always that simple. The concept map does have things like the unmapped segment, which can call off to another map. So it's not always a simple lookup of the table. And it may not even be that it's a normal concept map behind the scenes. So for example, Ontoserver has some algorithmic concept maps where there's not a fixed table of code to code, there's actually an algorithm that will compute the best match according to a translation, and that can happen behind the scenes as well. So when we call translate, we pass in a code. Once again, as a code and a system parameter. We specify which value sets we're interested in as the source and target, or we can do. And then the result comes back as a parameters object with match elements for each of the matching codes that the server has found. There is also a reverse parameter for the translate operation, but it's important to be very careful about the reverse use of translate. It's not the same as, it doesn't mean that the map you're using works in both directions. What it really means is you're asking the question, what codes map to this target code? What sort of codes map to this target code according to this map? Which is a subtly different question to what does this target code map to in the source value set? So here's an example. So this actually uses an implicit concept map. So SNOMED has a concept map in it from retired codes across to the codes that have replaced them. So when we call translate, we can pass through the URL of that concept map. We can say that the target code system, or target value set we're interested in is all of the SNOMED codes. And we can pass in the SNOMED code as a system and a code parameter. And in this case, this is code for what was called bronze diabetes, which is a retired code in SNOMED. And the server will come back and it will say, yes, I found a match for that. The relationship is that it's an equivalent code according to the concept map. And the target code is diabetes mellitus co-concurrent due to hemochromatosis. So at some point, the bronze diabetes code was retired from SNOMED because it's not a real thing. And it was replaced by this other code. So there's some other operations that we can use if we're doing more advanced analytics. So maybe we're trying to organize things into categories. Maybe we're asking search questions about correlations in the data. And there are some operations we can use for that. We could use the validate code operation to work out which codes are in a certain value set to break things up into categories. We might use subsumes to work out the hierarchy that exists between things, or we might use the closure operation, which allows us to do hierarchy queries, but in bulk rather than one at a time. And let's have a look at how that works. So closure is the most complex operation in the FHIR Terminology Services API. It is not idempotent. So when you call closure repeatedly, it will behave differently. The first thing that you do when you call closure is you create an empty closure table. The subsequent times when you call the closure operation, what you do is you pass in a set of codes that are added to the closure table, and the server will respond with all of the new hierarchy links that exist in your closure table as a result of those additions. And I'll show a small example of this as we go along. The result each time we do this is a concept map, and the concept map has the maps, the code to code maps in it, the new hierarchy relationships that the server finds as a result of these codes you've just added. This is a really useful operation if you want to query hierarchy, but you don't want to hit a remote server every time. You can build up a local closure table that tells you all of the hierarchy that exists just for the codes that you've seen. So rather than, if you're doing something with SNOMED, which has 600,000 codes, you don't have to ask the server the hierarchy relationships between all of the 600,000 codes and put that in your system, because your system might only see our codes. And so all you care about is the hierarchy that exists among those 1,000 codes. Then the closure operation can help you do that. So the first step of the closure operation, then we send through an empty parameters object with just a name for our closure table. And the server comes back with a concept map. The concept map has no group elements, so it has no actual mappings between codes, but it does tell us the version and confirms that name of the closure table. So we've initialized the closure table. In the second step, we pass through a single code. In this case, we pass through the hand structure code. And the server comes back with all of the hierarchy relationships that exist in the closure table because of the addition of that code. Now, it's the only code. So there's not going to be any new hierarchy relationships in the table. So it comes back once again with an empty concept map. Then in the next step, we can pass in some more codes. So we'll pass in the entire toe and the limb structure. And the server, when we do that, will come back with a concept map. And this time the concept map actually has some elements in it. So it tells us that the source and target are SNOMED codes. And it'll say that the limb structure concept subsumes the hand structure concept. No, it's actually the other way around. Yes, that's the way it reads in a concept map. And it'll also say that the limb structure concept subsumes the entire toe concept as well. So those two hierarchical relationships are new because of the codes that we've just added. Now, it's also possible when we're using that closure operation, the server is not required to maintain that closure table forever because the closure table is a stateful operation. So when we call that operation on the server has to store some state about that table of codes, and it's not required to keep that state forever. So it's always possible when we're using the closure operation that the server comes back to us and says, I don't know what the closure table is, you have to start again. So that's something to keep in mind if you are using the closure table to keep a local copy of all of the hierarchical relationships. You do need to be prepared to reinitialize that closure table if the server forgets your particular closure. So the final scenario I've got here is if we are building a FHIR server, so maybe we're deploying a copy of Happy Server or the Azure API for FHIR or the Vonk server or one of the other commercial servers that are out there. If we're implementing the search or validate functions on that server, that we can build an integration with a terminology server that makes those search or validate operations more powerful by using the terminology server. So for example, we can allow the server to implement something like a condition search, like this one, which says condition code below equals 732.11.009, and that means show me all condition resources whose code is some descendant of the diabetes concept. Alternatively, we can do a code in search. So in this case, this procedure code in and then this URL allows us to say, show me all procedure codes, all procedure resources whose code is in this elective procedures value set that I've constructed and put on my terminology server. So we can build in this, if we integrate our clinical data repository, such as the Happy server, with a terminology server, then we can support these terminology aware searches on the clinical data repository. When we do that, there's a bunch of strategies that are available for that. I won't go into a lot of detail for those. If you are interested in those, then please reach out either to the person who's building your clinical data repository, such as, maybe it's James Agnew if you're using Happy, or reach out to the person who's making your terminology server, because what you'll probably find is that they've already encountered this problem and they have strategies for how to integrate these servers. So you can call FHIR operations like the ones described. You can build virtual tables if your database supports that. And then you can do local caches of things to improve performance as well. Just before I finish, I thought I'd mention some work that we are doing as part of our Ontoserver development at the moment. It's not really part of Ontoserver development, but it's relevant to these FHIR terminology services API operations. We are doing some work with OpenMRS, working alongside SNOMED International to explore the development of a terminology module for OpenMRS. And what we're hoping is that will allow you to use these terminology operations from within OpenMRS so that you can have type ahead search for code systems like SNOMED CT from within OpenMRS. So we have been working with SNOMED International for a little while on this, and we're very hopeful of having a demonstration maybe in about 6 weeks or so. So when that happens, we'll be sure to let this community know so that people can check that out. So I know there is interest in OpenMRS here. So that's my presentation on the operations. If anyone has any questions, I'm very happy to answer them.
There is a question in the chat box. The question is from Dr.
Okay.
Rad. Is terminology aware search need to integrate with Ontoserver only? Is Happy alone able to do such research? Such a search?
Happy is it's a good question. It's a question better asked of James Agnew. I think it has some. The last time I looked, it wasn't able to do these kinds of searches. It may be that they've implemented some kinds of searches like this. If they have, it would be limited to value sets that Happy is able to process. So, for example, if you're using most SNOMED CT value sets, then Happy doesn't have that SNOMED CT functionality. If you're using, and I don't think it supports value sets that are built using filters either for whichever code system. The exception might be LOIC. I think their LOIC implementation is okay. So I don't think it does, but Happy does have fairly easy integration with a terminology server. So whether you're using a terminology server like Ontoserver or another terminology server, maybe if you've even got a Happy server that you're using as a terminology server, then it's a fairly simple thing to be able to configure your Happy server to use some other FHIR server as its terminology server for search, I believe. It's a fairly new feature. It only came out, I think, in December or November. But, I think James has made it easy to integrate the servers now. We have been looking at that, trying to improve the performance of that as well. So I won't say it's necessarily fast yet, but we are working on that with him.
Jim?
Yes.
Yeah, this is Alvin. Thank you. Can you comment on this architecture? AHIN, at the regional level, we maintain one Ontoserver. It is managed together with Cicero. We can have namespace per country if they want to extend it with their local codes. And maybe Cicero will be able to help us map those local codes back to an international code set. That's the first question. Can Cicero do that? The second question is, can countries then replicate that regional Ontoserver into their own Happy server, not an Ontoserver? Maybe if they want Happy server, then they use Happy. But if they want to replicate that with an Ontoserver, then also, of course, that's also possible. So is that architecture correct? That we can have one regional Ontoserver, make that available to the countries, and the countries can opt to just have a Happy server that syncs to the regional Ontoserver. Would that work?
It depends what those countries want to be able to do. So if they just want to be able to retrieve lists of codes, then yes, that would work. If they want to be able to search codes and have the performance search and the search order matching that exists in Ontoserver, then they would actually need to do that on an Ontoserver. So it's not possible to replicate all of the possible code searches that you might do and put that in a Happy server and have it work. But you actually do need to connect to an Ontoserver if you want that code search functionality. So for some usage scenarios, it would work. If you're just distributing lists of codes that then get baked into a system, you could just download that into a national Happy server from the regional Ontoserver, yes. But if you wanted to do code searching, then you would need a national Ontoserver as well as a regional Ontoserver. So it depends on your usage scenario.
Thank you. Thank you. There's another question.
Yes, so I can see there's a question about SNOWOWL. So SNOWOWL is really a tool for authoring SNOMED. And Ontoserver is not a tool for authoring SNOMED. We don't offer any support to help you author a SNOMED release. SNOWOWL will help you do that. That's its main thing. So so they're different tools. SnowOwl is an authoring tool for SNOMED CT. I don't know if they support other code systems, but certainly their main thing is SNOMED CT. They don't really have a runtime facility for letting you use SNOMED CT in the way that you can with Ontoserver. But on the other hand, Ontoserver doesn't help you with authoring a SNOMED CT code system. It helps you with using it for runtime purposes or build time purposes, but it doesn't help you author SNOMED CT.
Hello, Jim.
Hi.
I have a question about the parameter resource. Yeah, I saw a lot of parameter resource in your presentation, and what is this for? And it is only for working with terminology or for another purpose as well?
No, it's used quite a bit in FHIR. It's whenever you need a list of name value pairs. With a bit more structure than that, it can be nested name value pairs, for example. Then the parameters resource is how you do that. So, for example, any operation in FHIR, if you want to invoke that operation using a post HTTP post method, you can always pass in a parameters resource to represent what those parameters are for that operation invocation. I think you can also do it for a search request. So if you want to post a search request to a server and you want to put in the search parameters, you can use a parameters object body of the post request to send that through. So it's used all over FHIR, and I'd have to check, but I'm pretty sure parameters is a normative FHIR resource, so it's not changing. It's very simple. Yeah.
Thank you.
So I see there's a question there about ICPC and ICHI code systems. So Ontoserver does not ship with any code systems in it at all. So it's not accurate to say that Ontoserver has ICPC or ICHI. Ontoserver has special support for loading SNOMED and LOIC from the release formats of those code systems. So from RF2 and from the LOIC zip files that get released. But for all other code systems, you need to express them using a FHIR code system resource expressed using JSON or XL, and then add that into the Ontoserver. So Ontoserver, when you first stand it up, is empty. You have to add in your own code systems, either as a FHIR code system resource or in the case of SNOMED CT or LOIC using the distribution formats. I think as well, ICPC, I think there may be, depending on which country you're in, certainly in Australia, ICPC has some licensing restrictions. And if that's the case, it's on whoever's deploying the Ontoserver to manage those licensing restrictions. I don't think that is the case for the national ICPC, but in Australia, the ICPC variant is subject to licensing restrictions.
Thank you, Jim. And I think the Australian developed the ICPC for WHO, right? But it's still licensing for the whole country.
Yeah, well, we have I think it's ICPC 2+ that they use in Australia, they call it, and that's licensed from, I might be wrong, I think it's licensed from one of our universities. So, for example, I don't think we have a license for it, so we tend not to use it. But yeah, it's not free. The Australian variant of ICPC 2+. I'm not sure whether that's true or not for the WHO version.
Okay, thanks. My second question is that if we have the regional Ontoserver, do we have to have one organization in one country to maintenance all the Ontoserver and core system with and be used with others in country and other countries? How about the governance of the Ontoserver? That can you have a model for maintenance and governance how to use the Ontoserver?
Yeah, it's a complex question, and the different clients that we've deployed Ontoserver with have very different governance models that they use. So we have a fairly fine-grained permissions model in Ontoserver now, so that every code system or value set or concept map can have security tags on it that tell you which groups are able to either read or write that code system, and using the operations like I've described here today usually means that you need read permission on that code system. And then you manage those permissions and the membership of those groups using an authorization server. So it's all built on OAuth 2 based on the Smart on FHIR authentication and authorization model. And FHIR security labels. So every resource in FHIR can have a number of security labels attached to them, and that's where we store which group has either read or write permissions on that resource. So that was something that we built for the NHS. So when we originally deployed for Australia, they did not have a governance model like that, but the NHS insisted on that. So we've built that for Ontoserver now. So every resource can be tagged with who can either read or write from it, which lets you do a form of both governance, but also of multi-tenancy. So if you want to set it up so that there's some resources in a server that only some people can see, then you can do that using the security labels and those security groups. But it really would require sitting down and working out what governance arrangements you want for the resources on the server. So which code systems you're happy to make public for everyone to use, which ones are restricted to a country, and then there's the question of who manages accounts for that country. Yeah, so there's a lot of flexibility there, but it would require sitting down and working out what that governance model should look like.
In the UK, do the whole country licensing the Ontoserver?
It's a complex arrangement. No, the way it works is that there's a framework that has been procured by NHS Digital, and under that framework, NHS Digital themselves have procured one solution. It actually contains 5 Ontoservers, but they have one solution. And then each of the sub-organisations, so the trusts that exist in the United Kingdom, each of them can procure a solution for themselves if they want, and that applies for a lot of their research institutions. It can go down to the hospital level if they want to. So that framework allows them to procure that without having to go to tender, whereas otherwise they would have to go to tender for all of these things. So it's a very different model to Australia. In Australia, the way it was procured was that the health agency bought a license that let anyone in Australia get their own sub-license for Ontoserver for free. The UK did not do that. So I hope that answers your question.
Yes, quite a lot, because of if we have to think through this and to
very much so, yeah. Yep.
Jim, do you know how the UK used Nomad before Ontoserver?
Yeah, we've been hearing about how the UK used SNOMED before Ontoserver, and it was very variable. So some companies did it very well, and some companies did it very, very poorly, and some companies tried to do it and weren't able to do it, and so they didn't use SNOMED. So it varied. Like, there are some very good implementations, there are some not very good implementations. And part of the reason, or part of the thing they hope to get out of this framework that they've procured, and what we got in Australia, is you make it easy for people to implement it, and hopefully that means that they're more likely to implement it and that they will implement it better. So that's the aim.
Thank you.
You're welcome.
Jim?
Well, yes.
Sorry, I know we're over time, but I have this burning question. So, can our university, let's imagine there's a regional Ontoserver of AHIN, and inside that regional Ontoserver, there's a namespace for the University of the Philippines.
Okay.
And we upload there. We have experts in hepatitis, and we're working with the Ministry of Health and the World Health Organization on the hepatitis program based on the
Yep.
global framework. So, but this is just us, the University of the Philippines, putting all the terminology for the National Hepatitis Program on our folder, the University of the Philippines, and then we show it to the Ministry of Health. And when they say, okay, we like what you did, so is it so easy to just, import them into the Ministry of Health, making it official? How difficult or how easy would that be into their own namespace? And because it's now on their namespace, it's now a terminology that's available to all the health facilities in the country. Over.
Yeah, so the way that our permission system works is not really based on namespaces. It's based on security tags. So if you build up some, maybe it's code systems, more likely it's value sets and concept maps for hepatitis. While you're building them, you probably put a security tag that just says, this is writable by the hepatitis team at the university, and it's readable by, maybe it's the university clinic or something is able to read it just while it's in development. Then when you're ready to make it available to the Ministry of Health, then you might add another security tag that says this is readable by Ministry of Health employees.
Okay.
And that's only for that version of that resource. So if you're still developing newer versions as well and you want to keep them private, you can do that too. But yeah, you do it resource by resource. So when you're ready for a value set to be distributed to them, then you tag it with a security tag that they have permissions on, and then they can use it.
Thank you. That answers my question.
And that will persist across servers too. If you then send it through to their server, then it still carries those permissions across. They can change them if they want, but it does go with those permissions by default.
Thank you, Jim. Thank you. That answers my question.
I might defer any further questions. If people do have more questions, then my email is up on the screen. Well, an email that reaches me and all of our team. If people have questions, then please do send through questions. We respond pretty well to those questions. I will also share these slides after the presentation. I'll send them through and they'll get shared around. So we'd welcome more questions, and there will be more presentations in the coming weeks. So
okay. So, Jim, thank you very much.
Thank you very much. I've enjoyed it greatly.
Thank you, Dr. Jim, and thank you everyone for joining us in tonight's webinar. Please join us in the upcoming webinar in next Monday at 8 p.m. Manila time. Once again, thank you everyone, and have a good evening.
Thank you. Thank you. Bye.